Okay, hello everybody. You're welcome to my YouTube channel, All Mathematics Academy. Now, today we'll be looking into a nice topic in chemistry. It says redox reaction and the balancing of redox reaction. That is what we'll be looking into today. Yeah, what is redox reaction? Say redox reaction. This is the reaction of oxidation and reduction. So there is a combination of the oxidation reaction and then reduction reaction. So that is the combination of the two halves reaction. The first half reaction is for the oxidation and the second half reaction is for the reduction. Then if you add the two reactions together, that is the two halves reaction, if you add the two halves reaction together, so you get the redox reaction. Now let me start with the oxidation reaction. Now don't forget, I say redox reaction is the reaction of the oxidation reduction. Say redox reaction also means oxidation reduction reaction. Yeah, also means oxidation reduction reaction. Okay, now in oxidation reaction, electrons moves. That is, in oxidation reduction reaction, electron is being gained or electron is being lost in redox reaction. Now, in the case of oxidation reaction, electron move from atom to another atom in oxidation reaction. Now, let's say we have two atoms, atoms A and then atom B. Then the movement of electron from this atom A to this atom B, that is the what? The redox reaction. That is, this atom A is the one losing electron. So we say this atom A is what? Is oxidized. Why this atom B, which receive this electron, we said it is reduced. So that's why I say redox reaction is what is the reaction of the oxidation and the what and the reduction. So in this atom A, oxidation takes place, and then in this atom B, reduction takes place. So that is that about that. Now let me write out something nice now. You can say reduction is the gain of electron. While oxidation is the loss of electron. So reduction is the gain of electron, while oxidation is the loss of electron. So in this reaction here, A is being oxidized, while B is being reduced. Now let me write out some terminologies that you can make use of. Very useful, very useful. Oil rig. So this oil means oxidation is lost. So if you remember oil, okay, O stands for oxidation I stands for is and L stands for loss. And R, reduction is gain. That is, R stands for reduction, I stands for is, and G stands for gain. So, in a redox reaction, the first atom or one of the atom is either to lose electron or to gain electron. Okay, now let me write another terminology. LiHo and Ja. LiHo, L means what? Loss of electron, and Gr means what? Gain of what? Of electron. That is, loss of electron is oxidation, gain of electron is reduction. Oxidation is loss of electron, reduction is gain of electron, loss of electron is oxidation, gain of electron is reduction. So you can make use of these terminologies or of these acronyms. Okay, now let us look into an example of redox reaction. Now, let us look into example of redox reaction. Okay, that is example of a reaction in which oxidation and then reduction takes place. So I'll be using sodium and chloride. Sodium plus chlorine give us sodium chloride. Okay, now let me write out the ionic equation. Sodium is a melter, chlorine is a gas as one of the halogens. And then in an ionic equation, the metals lose electron or they release their electron. They donate their electron. Why the non-metals receive the donated electron? The oxidation number of sodium is 281. And then the oxidation number of chlorine is 287. So sodium needs to donate this outermost electron, and then chlorine needs to gain this electron for chlorine to complete its orbit, while sodium needs to release this electron for sodium to complete its orbit. So they say metal will donate electron while non-metals receive the electron donated. So in this case, if sodium donate the electron, then I have Na plus Cl, and chlorine receive the electron. So whenever sodium donate electron, sodium becomes positively charged, and then chlorine becomes negatively charged. And then sodium donate how many electrons? Sodium donated 1 electron, that's why I have Na plus. And then chlorine received just 1 electron from chlorine, that's why you have Cl minus. So these are what? Ionic compound. Now, sodium and chlorine can come together because they have what? They have opposite charges. That is, opposite charges attract. Are you following my explanation? So sodium and chlorine can come together because they have opposite charges, plus and negative. So whereas opposite charges do what? Do attract. Initially, sodium and chlorine are electrically neutral atoms. Sodium and chlorine are electrically neutral atoms. That is, the electron of sodium here initially should be 0. The electron of chlorine here initially also should be 0. So that is why I say they are electrically neutral atoms before this reaction takes place. That is, they are both, the oxidation number here 0. The oxidation number here is 0. But after the reaction takes place, the oxidation number of sodium has increased to 1 from 0, while the oxidation number of chlorine has decreased from 0 to -1. So when the oxidation number of sodium increased to 1, that is, sodium has been oxidized. And when this is increased, and when the oxidation number of chlorine decreased from 0 to 1, so we say chlorine is being reduced. So sodium losing electron, which means sodium is being oxidized. Chlorine gaining electron, which means chlorine is being reduced. Then let me write out chemical equation for this kind of oxidation and reduction. Now let me start with chlorine. Chlorine needs one more electron. From this oxidation number, I say 287, that was the oxidation number of chlorine. So chlorine needs one more electron for it to complete his electronic shell. This is for chlorine. You have 3 shells for chlorine. So the first shells have how many electrons? That is 2 electrons. 2 electrons. The second shell have 8 electrons. And the third shell have 7 electrons. That is, chlorine needs one more electron here. Chlorine needs one more electron. So then if I had the electron here, so I have E minus. So E minus is a symbol to represent electron. Then when chlorine received the electron, that is when chlorine gained the electron, chlorine become negatively charged. That is also applicable to sodium. Sodium needs to lose one electron. But we cannot write it this way, that sodium is losing one electron. It cannot be written that in chemistry. It cannot be written that way in chemistry. So instead of writing minus E minus here, so we say sodium will give us Na plus E minus. That is, sodium is having enough electron, is having plus 1 enough electron. Then sodium needs to give out this electron for it to be neutral here. Sodium needs to give out electron for the oxidation number to be increased. So this is the reduction. This is the reduction. That's the reduction side. Okay, now this is called half reactions, half equation of the redox reaction. This is called half equation of the redox reaction. Then if I had the two half equation of the redox reaction together, then I have my full redox reaction. So I will have sodium plus chlorine having initial 0, having their initial electron as 0. Then sodium is being increased to 1 while chlorine is being decreased to 1. So this is oxidation. This is the oxidation. While chlorine is the reduction. So we say sodium is the reducing agent here. Reducing agent. Why chlorine is the what? Is the oxidizing agent. Sodium is the reducing agent, while chlorine is the oxidizing agent. Sodium oxidized is being oxidized, while chlorine is being reduced. So take note of that. Take note of that. Now let us move to the next example. Magnesium plus oxygen gas. This gives us magnesium oxide. So the oxidation number of magnesium here is being increased to 2, while the oxidation number of chlorine is being decreased to -2. Now we can see magnesium, the oxidation number of magnesium increased, while the oxidation number of chlorine of oxygen decreased. So oxidation increased. When the oxidation is being increased, we say it is oxidized, that is loss of electron. When the oxidation decreased, we said it is reduced, that is gain of electron. When oxidation is being increased, so we say it is oxidized. So that is loss of electron. Loss of electron. Also, when the oxidation decreased, so we say it is reduced. That is gain of electron. Now, substances that is being oxidized is known as reducing agent, as I have said earlier, and substances that is reduced is known as oxidizing agent. Substances that is being oxidized is known as reducing agent, while the substances that is being reduced is known as the oxidizing agent. And let's move to the next page of the lecture. Writing out the half reaction. That is, we want to write out the half reaction of this given redox reaction. So writing out the half reaction, how can you write out the half reaction of that given redox reaction? So you start with your magnesium, starting with the magnesium. So magnesium, that will be Mg2 plus, that will be plus 2E minus, oxidized. Then the next one is oxygen, that's oxygen plus 2E minus, and give us oxygen. So that one is being reduced. So it gives us oxygen that is being reduced. That's O2 minus. So reduced. So this is the half reaction, that is half equation of the reaction. Now let us look into another example, zinc reacting with hydrochloric acid. So it gives us hydrogen gas plus zinc chloride. Now, here the initial electron is 0. Take note of that. But when hydrogen reacts with a gas, the oxidation number is +1. And don't forget, chlorine is -1. Then H2, the oxidation number here is 0. Then your zinc has been increased to 2. Then your chlorine is -1 here. Now, look at this very well. Which one is being oxidized and which one is being reduced? We can see zinc is being oxidized. Why? Zinc gain zinc, the oxidation number of zinc is being increased. So we say zinc is being oxidized, while the oxidation number of hydrogen chloride is being decreased. Can you see you have 0 here for the hydrogen? Though chlorine is not decreasing, but since the oxidation number of hydrogen is being decreased, so we say this is the reducing part. That is, this is the reduced compound. So we say zinc is being oxidized. And since zinc is being oxidized, so we call zinc as a what? Reducing agent. Reducing agent. Then we say HCl is reduced. Then since HCl is being reduced, we say HCl is an oxidizing agent. So is an oxidizing agent. Okay, now let's look into another example. That's example 4. Say methane reacting with oxygen gas. So this gives us CO2 2 minus plus H2O 2 minus. It is -2 for the oxygen. Now, don't forget, the oxidation number of hydrogen is +1. Oxygen is -2, but at the left hand side here is still 0. The oxidation is 0 here. And here, now let's calculate the oxidation number of carbon here. Now, I'm sure you know how to calculate oxidation number of any element in a compound. This is how you are going to do it. Now let's calculate the oxidation number of carbon here. That will be carbon plus 4 into brackets oxidation number of hydrogen, which is 1. This must be surely be equal to 0. So you have C plus 4 is equal to 0. Then you have C is equal to -4. So the oxidation number of carbon here is -4. Now let us calculate the oxidation number of carbon here. We know the oxidation number of oxygen here is -2. So that will be carbon plus, don't forget this 2 into bracket -2 give us 0. So we have carbon minus 4 equals 0. So we have carbon is equal to +4. Now the oxidation number of carbon here is +4. Then we put the +4 there.